All right, everybody. Good morning. Oh, let's try that again. Good morning, everybody. Thank you. Welcome to the Clark Planetarium. Salt Lake County and the Clark Planetarium are thrilled to have all of you join us today. There's a lot going on, of course, in our building right now and out in the desert really, really soon. So we are really happy to have all wonderful students. We've got a bunch of different groups here, so we hope that you find all of this as fascinating as we do, but we're talking about sample return mission, planetary science, and what this can mean for all of us as we seek to more deeply understand our place in the universe. So it's just wonderful to have you all here. Our guest speaker today is Dr. Lori Glaze, sitting right down here. We'll get her up in just a moment. Before we do, a few words about her, though. So she's the director of NASA's Science Mission Directorate's Planetary Science Division. Planetary science is focused on spaceflight missions and scientific research that addresses the fundamental questions about life in the universe, evolution, and understanding planetary environments. So we are thrilled to have her with us today. She's been doing this for a while. She'll tell you a little bit more about her background. I'm going to turn the rest of the time over to Dr. Glaze.
Thank you. Hey, everybody. It's good to see you here today. Glad that y'all could all come out. I'm really excited to talk to you about some of the amazing stuff that NASA is going to be doing right here in your backyard, coming up on Sunday. But first, let me just make sure we kind of set the bit. Where are we here? How many folks in the room have heard of NASA before? Excellent. How many people in the room have heard of the OSIRIS-REx mission? NASA's OSIRIS-REx. Excellent. So we got about half and half here. Some folks that know what I'm going to be talking about, and some folks this might be new. So, but that's going to be, it's going to be a really fun mission. We're going to tell you all about it here today. Okay, so as was advertised, I'm going to tell you a little bit about myself first and where I came from and how I got here. You know, you heard my title, and it's just a bunch of words, and what does all that mean? A planetary scientist, director at NASA, you know, what is all that? Well, I'm just a person, right? I started out like y'all in school, and I was really interested in math and science. I was particularly interested in physics. And so I got a bunch of degrees in physics and in environmental science. I was particularly interested in how do volcanoes work. And so that's kind of where I started out. I studied volcanoes on Earth. I used satellite images to look at volcanoes, and then I also did a lot of mathematical modeling to try and understand how lava flows work, how explosive ash columns work when they have an explosive eruption. And so I got really interested in the volcanoes. And then when I got my first job at the Jet Propulsion Laboratory, a long time ago, I started learning that there are volcanoes across the solar system. Did you know that? Did you know there's volcanoes all over the place in the solar system? Mars has the largest volcano in our solar system, not active today, but Olympus Mons is the largest volcano in the solar system. Io, that's a moon of Jupiter, is got the most active volcanoes in the solar system, more active than Earth even. And then I also learned that Venus is covered in volcanoes, and Venus is very mysterious, may or may not still have active volcanoes, we don't know. We just had some recent research, just came out in December, that looks like the first time we ever found definitive evidence of active volcanoes on Venus. But anyway, very cool. So I was always interested in volcanoes. I got interested in planetary science. And through all of that and all of my work over the years, trying to develop new mission ideas to fly to Venus and study and learn more about Venus, eventually I ended up at NASA headquarters, where now I get to oversee all of the really cool science and missions, flight missions that we do for planetary science. Things like the Mars Perseverance rover. You can see me down here at the launch there in 2020. And then you can see my office is down in Washington, D.C. NASA has facilities all over the country. I work at headquarters, which is in Washington, D.C. And then you can see my amazing team, because nobody does the things that NASA does by themselves. We have huge teams that have lots of different backgrounds and lots of different experiences in order to do the great stuff we do. So I thought I'd start first by just talking a little bit about science at NASA. Why does NASA care about science, and what kind of science do we do? So just in a broad sense, really interested in making sure we can protect and improve life here on Earth. We are also looking for life in the universe. Where does life exist? Does it exist? And if so, where beyond Earth? And then just understanding the secrets of the universe. And so within NASA, we have to divide things up because that's a pretty big space to think about. So we're divided up into different organizations. We have a big group that just studies Earth because Earth is pretty amazing and there's a lot of important things we need to understand about how our own planet works. So we have a bunch of folks that just study Earth. And then we have a whole group of people that just study the sun because that's a pretty important part of our life, everyday life here on Earth. So we have a whole group that studies the sun. My group is studying planetary science, so I study everything else. My group studies everything else in the solar system except the Earth and the sun. And then we have another group called astrophysics, and they're really interested in everything outside of the solar system. So that's how we divide it up. And so within planetary science, the kind of things you've probably heard of that we work on in planetary science, some of our missions like the Lunar Reconnaissance Orbiter, which has been taking pictures and collecting data at the moon now for, I think, 12 or 13 years, doing an amazing job there. The New Horizons mission, it flew by Pluto in 2015, where we got that amazing picture of the heart on Pluto. Juno, which is a mission that's flying at Jupiter right now, taking some amazing images of the cloud formations on Jupiter. Of course, Perseverance rover, Percy, and then her sidekick, Ingenuity helicopter, which was the first ever controlled powered flight on another planet. Pretty exciting stuff. So we're not here to talk about those, though. We're here to talk about asteroids today. We're going to talk about all things asteroid and why we care. What are asteroids and why do we care? And why do we care about the OSIRIS-REx mission? So asteroids are actually leftover remnants of the materials that made up all the planets and the moons in our solar system. So sometimes they're rocky, sometimes they're icy. We've got a bunch of asteroids you can see in this picture here that are found in the main asteroid belt between Mars and Jupiter. And so that's where you find most of them, but there's actually a whole lot of asteroids in other different places in the solar system. And we're going to talk about some of those here today as I walk through. But these materials are particularly important because they tell us a lot about the early times in our solar system, about 4.5 billion years ago, before there was an Earth and before there were other planets. So what we do with these asteroids, we call these small bodies because they're smaller than the planets and smaller than the moons of the planets, but small bodies, but big science. And the reason we say that is, again, these are the leftover pieces, all of the materials that collided together to make the planets and make the moons. This is what's left over. So if we want to know what our planet was made of, what were the building blocks of our planet, what were those materials like that built up our planet, we need to study asteroids because it's still preserved in these asteroids. These asteroids also potentially carried the elements needed for life, including perhaps water that's tied up in minerals and rocks on these asteroids, as well as the organic molecules that are the building blocks for life. And so if those materials are carried on these asteroids and they were crashing into all the planets in the solar system, that may be what delivered all of the basic building blocks that eventually turned into life on Earth. We can also learn about active processes that are going on in the solar system, and what that means. There's lots of little asteroids out there, little meteoroids that are out there crashing into each other and rearranging and changing the surfaces of the other asteroids out there. So that's a big part of what's going on in our solar system. Hazards. You know, sometimes, every now and then, an asteroid hits Earth. In fact, you probably don't know, we actually get a couple of these every week. There's several that come in between the Earth and the Moon all the time, but most of them are really tiny and they burn up in the atmosphere. But if a big one comes along, that would be a problem. And so we want to make sure we understand where they are, how big they are, and when they might intersect with Earth, because that is an important thing to know. We'll talk a little bit about that one too. And then finally, asteroids could contain some resources that might be helpful in exploration. It could be minerals that might be useful and valuable, but it could be things just like water that's tied up in the minerals and the rocks on the surfaces that, if we're exploring deep space, might be useful to help the astronauts have the things they need to explore. So I'm going to talk a little bit about asteroid autumn, what we're calling asteroid autumn, which is where we are right now in the fall. Several missions that NASA's doing that are visiting different types of asteroids in different parts of the solar system that can each tell us a different part of the story of where we all came from. So, of course, OSIRIS-REx, we're going to get to that one in a minute. I'm not going to talk about it just yet. I'm going to talk about some of the other ones first. But I'm also going to talk about DART, which is a mission to help protect us from a potential impact in the future. Psyche, that's going to be launching on October 5th from Florida, and Lucy. So we'll talk about each of these here first before we go to OSIRIS-REx. So I want to talk about DART. Did anybody hear about the DART mission last year? Anybody? This was a mission that crashed into an asteroid. Anybody hear about crashing into an asteroid? This is the first time that humans ever changed the path of another celestial body in the solar system. So pretty cool. So here you can see DART stands for Double Asteroid Redirection Test. And you can see here the two asteroids, a main asteroid there called Didymos and a little one called Dimorphos. And you can see Earth down there in the lower left where we were watching and observing this whole thing happen. And what you saw there was that our spacecraft, the DART spacecraft, came into the field of view there and then crashed on purpose into that smaller little moonlet that was orbiting around the big asteroid. And when it did that, it slowed it down just enough that it changed its orbital period around the bigger asteroid. And we actually changed its orbit by 33 minutes out of almost 12 hours. So maybe not a big change, but the important thing is that if you actually knew that an asteroid was on a path to collide with Earth and you could slow it down or change its orbit just enough that over time that change would add up, then we could hopefully get Earth out of the way so that when that asteroid passes over Earth's orbit, we're not there. And that would be the whole point of that, to help protect us in the future. So let's just walk through it. If you all didn't watch it real time a year ago, here we are on the spacecraft. You're riding along, looking at the images that we were using to help navigate the spacecraft in real time. It's all done autonomously because you can't joystick something that's millions and millions of miles away. The little asteroid there was only 1 pixel about an hour before we hit it, and we used the cameras to hone in and really nail down the target as we got closer, and then you can see it targeted perfectly right into the center of the asteroid, and you're going to see it slow down here. There we go. One of the only times we ever celebrate when we lose our signal and we crash the spacecraft. But how cool is this? We actually did that, and then immediately, the picture on the left here is one of my favorites because I actually had this little video on my phone within 5 minutes of hitting the asteroid. And what you're seeing there is actually images taken from a telescope in South Africa, the Atlas telescope. And the object that's moving across is Didymos, the larger of the two asteroids, because we couldn't even see the small one from Earth. It was so tiny. But what you can see is that vaporization, all of the vapor coming off of the little asteroid when we hit it with the spacecraft. So when we saw that within 5 minutes, and we knew what we had targeted right dead on, we knew we did something here. This is going to be good. So the image on the right is actually taken from a little tiny CubeSat that we took along with the DART spacecraft, and it carried some cameras, and you're looking here really right into that cone of ejected material coming off of the asteroid. And so you can see all the structure and all of the rays of rocks coming off of there. That was really super cool. So that's pretty fun. So that's our area. We call it planetary defense. Our planetary defenders are out there making sure we can find those asteroids. Once we find them, we want to know what their trajectories looks like so we can predict when they might be of danger to Earth. And if anybody ever asks you, and I get asked a lot, no asteroids that we know of have any danger to Earth for at least 100 years. Okay, so that's a good thing to know. Of the ones we know of, we still have more we need to find, but that's a good thing to know. So let's change over. I mentioned that we've got another mission to an asteroid that's going to launch on October 5th. So I mentioned that most asteroids are in the main asteroid belt. This mission here, Psyche, is going to an asteroid in the main asteroid belt. That mission, DART, I said, that asteroid is the kind of one that could come near Earth. So that's a different kind of asteroid. It's called a near-Earth asteroid in a different orbit. We'll talk about that some more in a second, too. Psyche is in the main belt. The Psyche mission is going to visit an asteroid also named Psyche. And the reason we're going to this particular asteroid is because it is very, very unusual. Most asteroids are made of, what do you think asteroids are made of? Just shout it out. Rocks, ice, yeah, rocks, ice, lots of rocks. A lot of the asteroids we think have a lot of carbon, right? We call them carbon-rich asteroids. So a lot of them have a lot of carbon. OSIRIS-REx is going to visit one that visited one that had a lot of carbon. This particular asteroid, Psyche, is one of only nine out of millions of asteroids that we've detected, only 9 that we think are mainly made out of metal, made out of iron and nickel. And it's actually the largest of all of those iron and nickel asteroids. So what does that mean, an iron and nickel asteroid? Why are there so few, and why is this so interesting? And the reason why is, I see some hands going up, and I know there's a lot of questions. I tell you what, I promise we're going to do questions at the end, but I want to make sure we get through the stuff here, and then we'll have time for questions, I promise. So the reason it's so cool is that we think it's possible. You know, Earth and all the planets have a metal core, an iron core. And so it's possible, maybe, that a bunch of material came together, started to form a planet, but then had a big impact that blew off the lighter rocky material, like the crust, blew off that crust, and then left exposed that inner metallic heavy core. Maybe. This is going to be a mission of discovery. We don't know what we're going to find. We don't know what that would look like. We have no idea. So this is truly going to be a mission of discovery. We're going to go to this amazing, unique asteroid called Psyche. So if you want to follow along on October 5th, hopefully, if the government's still open, you'll be able to follow that online. We'll see. It's a joke for the parents. So let me talk about another one. So asteroid autumn. We've got the anniversary of the DART impact 1 year ago. We've got Psyche launching on October 5th. And then on November 1st, we have another mission called Lucy that's going to do a flyby of an asteroid. Now, Lucy is going to go visit some special asteroids. These are not in the main asteroid belt. These are called Trojan asteroids. And if you take a look down here in the bottom right, I'm going to point this out. This is a model of the solar system. You can see all the inner planets just spinning around the sun really, really fast. Out on the outer part there, you see that little orange dot. That's Jupiter. All of those green dots are Trojan asteroids. And the reason they're called Trojan asteroids is they're kind of trapped in an orbit, same distance as Jupiter from the sun, but they're held gravitationally by the pull between both Jupiter and the sun. So they lead Jupiter in its orbit and they trail Jupiter in its orbit. So it's really interesting. You may not believe this. Those Trojan asteroids are closer to Earth than they are Jupiter, even though they're in Jupiter's orbit. Isn't that cool? Fun fact. So coming up November 1st, we're not quite out to the Trojan asteroids yet, but we are going to be flying through the main asteroid belt, and we're going to fly by a little asteroid called Dinkinesh. And that's going to allow our spacecraft and our science teams and all our engineers to test out all of their navigation software and all of their operations plans. So we're going to test that out on November 1. So a lot of exciting asteroid stuff coming up. Asteroid autumn. All right, but now let's talk about OSIRIS-REx, because this is really, as I said, this is what's coming up. It's in your backyard, and it's going to be a lot of fun. So OSIRIS-REx is a mission that's going to visit a near-Earth asteroid. So we'll talk a little bit more about that in a second, but it's going to a special asteroid called Bennu, or it went to an asteroid called Bennu. So you can see here Bennu on the left. Compared to the Empire State Building, it's just a little bit bigger than the Empire State Building. And we chose this particular asteroid because it's carbon rich and interesting from the perspective of what it may have been able to, would have delivered to a planet like the similar carbon-rich asteroids if it were delivering carbon and water and things. It's also big. So that means that it's something that we could send our spacecraft and try and navigate around it and be able to get a sample from the surface. A small one would be hard. And then it's also a near-Earth asteroid, meaning that it's in an orbit that comes by Earth every now and then, so it's close by. In fact, over here shows you what its orbit is. In this particular diagram, Earth is in the blue circle, and then you can see Bennu in the green circle. It kind of orbits inside of the Mars orbit and crosses over Earth's orbit every now and then. Again, Bennu's not going to hit Earth. The earliest time it could possibly hit Earth is like 150 years from now, okay, at least, maybe 160. So no panicking just yet, but it is a near-Earth asteroid. It is potentially hazardous. It does cross over Earth's orbit. So it's the kind of asteroid we'd like to learn a little bit about for planetary defense. All right, so a little bit about the OSIRIS-REx mission and its story. How did it get to where it is today and where we're going to be on Sunday morning? So it launched in 2016, and it started its cruise to Bennu. It arrived in 2018, and you can see here an image of Bennu there, just a compilation of all the images that we collected at Bennu. An amazing place, beautiful asteroid. We were really surprised. We expected the asteroid to have lots of fine-grained material on the surface that was going to be super easy to sample. We figured it would be like going to taking a sample of material off the beach, sandy beach. This is not a sandy beach. These are giant boulders. It has a lot of rocks and a lot of big rocks. And we saw it and we went, whoa, this is going to be a challenge, right? Because number one, we need rocks small enough we can pick up with our sample system, and we need to do it safely. And there's a lot of big rocks here. So we spent some time doing our initial survey. We kind of orbited, which orbiting around an asteroid is hard because there's not a lot of gravity. So you kind of do these weird dancing maneuvers around it. So we did that for a while, did a survey and really studied the surface to try and find where would you possibly be able to grab a sample. You want one that's scientifically interesting, that has a composition we'd like to learn about, the carbon and the organics and the water minerals, those types of things, but it needs to be safe. So we mapped it out. We carried along several instruments. We had a camera. We had a laser altimeter. That's a big word, laser altimeter. But it bounces lasers off the surface so you can tell the topography on the surface, how tall and how high are the features on the surface. And then we had a bunch of what are called spectrometers to tell us what the compositions were on the surface of the materials. And we could see that, yes, we found an asteroid that had a lot of organic material on the surface. And it had a lot of minerals that looked like they'd been altered by liquid water. So this is exactly the kind of asteroid we wanted to visit and the kind of asteroid we wanted to get a sample of. So we finally used all that information to pick a landing site. And this is a little place that is called Nightingale Crater. This is the place where we ultimately decided to take the sample. And I don't know about you, but if I turn around and watch this, I'm going to get dizzy. So you guys enjoy. But what you can see now kind of rotating around to the back is a big giant boulder that we called Mount Doom. That rock, that little boulder is like a 2-story high building. And that kind of gives you a sense of scale. And just be thinking now, I'm going to show you the next slide, kind of how we went in and did this. But, you know, we picked this spot because we thought down in the middle there was some smallish grained material that we'd be able to pick up with our sampling system. But we knew getting in and out of that spot was going to be hard. The asteroid is moving. It's rotating. It's spinning. The spacecraft is coming in. It's moving. It's got to go in, get the sample, and pull back out safely. So we thought, well, it's going to be hard, but we think we can do it. But just for a sense of scale, I already told you that big boulder is like a 2-story building. We had to fly in and hit an area that was about the size of 6 parking spots that was sitting next to this 2-story building while the parking lot and the 2-story building were moving. And we were moving. And you have to go in, grab the sample, and then pull back out without ever hitting that big boulder. But they did it back in October of 2020 successfully. And you can see in that little picture up there at the top where this sample head went down and touched the surface and grabbed some samples to bring back. What's interesting, and you can't really see it from this image, but let me describe it. This asteroid is made up of all of those boulders, but it's not solid. It's like a really loose kind of collection of rocks. And someone I heard describe it like a ballroom, you know, at McDonald's or Chick-fil-A, right? Where you go in there and you stick your hand in the balls and it just keeps going. That's what happened here. The sampler, it came down and it hit the rocks and it just kept going. And if we hadn't fired our engines to pull back out of there, it would have just flown right through the asteroid. Those rocks are just not really held together very well. So really, really interesting properties. We learned a lot about what these kind of blocky asteroids are like. So we collected our little sample. Here it is in that sample head. That sample head is, you know, about this big, like a dinner plate size. And what you see in the image up top is we wanted to collect a few grams of a few ounces of this material. We saw this image that we had a camera back on the spacecraft when we pulled out away, and you could see little pieces of particles flying out of our sample head. And we went, holy cow, we think we got a lot of samples. In fact, we think we're losing some out of the sample head. We need to button it up fast. So you see it there, we're getting closed up in the sample container, in the sample return capsule, so that it could safely come back to Earth. So after we did that, we had to wait around until all the planets were in the right alignment, and then in the spring of 2021, started the trip back to Earth. And that trip is now almost complete. Sunday morning, yes, yay. Who said yay? Yes, yay! You got it. That's right. Sunday morning, 8:55 a.m., that little sample return capsule that you just saw a picture of in space is going to enter Earth's atmosphere and land at the Utah Test and Training Range just down the road. So pretty exciting stuff. I think this is going to be a pretty phenomenal event. This is a one-of-a-kind, unique sample that our scientists are going to study today, but it'll also be useful for scientists for many decades to come, including all of you guys in here when you get to be scientists or engineers. Once we drop off the sample, a lot of people say, well, what happens to the spacecraft after you drop off the sample? We're actually going to keep using that spacecraft. We're going to rename it as the OSIRIS-Apophis Explorer because it's going to go explore another asteroid called Apophis. Yay! Yes, thank you. Another yay. Yay, Apophis. All right. So let's kind of walk through and talk about what you can expect to see or hear or not on Sunday morning. All right, so here we are. Today we're in Salt Lake, right? Salt Lake City, and you can see off to the west there, the Utah Test and Training Range and Dugway Base there. You can also see that white oval up there. That's the targeted area where we expect to land that entry capsule. This space was selected because it's a safe place where no humans shall be harmed. And there's less than a 1 in a million chance of it landing outside of that oval. In fact, I was just on the briefing this morning with the team, and they've done already the last maneuver they're going to make, the last firing of the engines on the spacecraft. And right now, the latest trajectory shows them landing smack dab right in the middle of that ellipse. So hopefully all goes well. And even if it doesn't, we still land within that ellipse. So don't worry, it's going to be okay. It's all good. Okay, so here's just a little animation that shows you where it's coming in from the west. You'll see it there at about 4 hours before it lands, it gets released. At 13 minutes before it hits the top of the atmosphere at 27,000 miles per hour. The exterior of that entry system as it comes through the atmosphere, 5,000 degrees Fahrenheit. And then it releases a little tiny parachute, which slows it down a little bit, then a bigger parachute to slow it down a lot. And then it's going to touch down right in the middle of that ellipse perfectly at about 10 miles per hour. Soft, gentle drop. I'm going to answer questions at the end. I'm sorry. We're going to keep going. Okay. The scale. The entry system itself is about the size of a car tire. Okay? So that's how big it is. It's not very big. It's pretty small. Okay, good question. Good question. All right, so I want everybody to make sure you take a picture of this or make a mental note, because this is how you can follow along if you're not actually out on the site. This is what where we're going to be broadcasting, have a live broadcast on Sunday morning. Also, tomorrow morning, right here at the Clark Planetarium, the United States Postal Service is going to be releasing a new stamp in honor of OSIRIS-REx. Yay. So get your stamps. So that'll be fun. That'll be fun. Yep, and follow along. All right, so what happens next? Here you go. And let me just say, I can give you expectations of what you can see or hear or not, okay? It's going to be 8:55 in the morning. The sun is already up. Yes, that thing's going to be coming in at 27,000 miles an hour and 5,000 degrees Fahrenheit, and it will glow. But in the daylight, you will not be able to see it unless you have on infrared goggles, okay? With your eyes, you won't be able to see it. If it had come in the middle of the night, it would have been spectacular, but we can't change orbital dynamics. It's coming in when it comes in. And then it will have a sonic boom, but because of variability in the atmosphere, it kind of depends on where you are, and maybe you can hear it or maybe not. But if you hear it, let me know. That would be cool. So what happens next? Once it lands in the desert, we have a whole crew, a whole team of folks out at UTTR. We've got some aircraft that are going to be taking data as it comes in to give us new scientific information about that entry system. We'll collect that as it flies in. We'll have radar systems tracking so we know exactly where to pinpoint where it landed. And then we're going to send some helicopters out to go retrieve that sample system. We kind of pick it up in a nice, gentle little hammock, and we carry it back to the main hangar out at Dugway. And there we have a little temporary clean room that we have set up, a special clean room. These samples are really special, and we want to keep them as pristine as possible. Remember, these are pristine remnants of our early solar system. We don't want to contaminate them with our own biology. So we want to keep them as clean as possible. So we have a temporary clean room. We'll get the receiving capsule all kind of secured and buttoned up in a little container. And then we're going to load it onto a C-130 aircraft, and we're going to fly it to Houston. Why are we flying it to Houston? We're flying it to Houston because that's where NASA keeps all of our precious samples that we study for science. So we have all of the Apollo samples there. We have meteorite samples there. And that's where all of our curation experts and our laboratories are for samples that we bring back to Earth. So we're going to take them there. And there we have another special clean room all set up where they'll spend the next, 6 weeks or so, really going through and carefully disassembling the whole thing. That whole entry system, making sure we categorize every grain and we know exactly what material we brought back. And so you can actually follow along sometime in mid-October. I think on October 11th, we're planning to do a kind of a media briefing or something for the public to let everybody know how much sample did we get and what do we think that sample looks like. And then those samples can be studied by our scientists on the OSIRIS-REx team, but we'll also make them available to anyone in the world that wants to write a proposal to do science with those samples. And then we actually take a large fraction of the samples, like 75% of the sample, and we lock it away. And we do that so that you and your children and your children's children can have access to that sample many, many decades into the future. We did that with Apollo. We just opened a new Apollo sample a few years ago that had never been opened before. Amazing. So we have new scientists and new instruments able to study those samples. So we can learn amazing new things. So I'm going to close it here. I just want to stop by saying that, again, like I said at the beginning, none of this is done by a single person. It's teams and teams of people. This is just a small part of the OSIRIS-REx team, the science team, not even the engineering team, which is probably 10 times larger than this group. It's an enormous group of people. And the one thing I want everyone in the room to take away is that the amazing things that NASA does, yes, we have amazing scientists, yes, we have amazing engineers, but none of this happens without everything. We have amazing accountants, we have amazing lawyers, we have amazing doctors, we have graphic artists, we have animators, we have communication specialists. NASA has a job for everyone, and everyone is needed to do the amazing things we do. So I know I put you off for questions. I think we have some time left for questions, hopefully. And I'm going to take as many as we can. And then I also want to make sure when you leave the room today, out the back, we have set up, I think, a table outside that's got some special NASA things you can take away with you. I'm going to get to the questions. Hold your hands. In addition to some of the cool NASA planetary stuff that I brought, I also brought some special NASA eclipse glasses. Because if y'all have been paying attention, there's also going to be an annular eclipse in your backyard coming up in October. So that's pretty cool too. All right, let's go to some questions. I'm going to go way to the back first. Don't give up on me. We'll get you together. Just shout. I'll repeat the question. Bennu, readings on the internal structure of Bennu. So that's a really, really good question. We have from the gravitational pull of the asteroid while we were there trying to navigate, we learned a lot about its gravity and its density. I don't have the data on the top of my head, but I know there was a whole series of papers that were published that talk about what that interior structure is like. But it's, you know, again, most of it is this loose conglomeration of rocks. You bet, you bet. Okay, let's go to another question over here. I'm going to go to that side of the room next.
Stopped. What happened with that?
Exploring the deep seas and then stopped. I'm not sure quite what that's referring to. There are still a lot of programs that explore the deep seas. Again, most of that is for earth science. So my good friends in earth science do a lot of that. Ocean drilling program. Also a bunch of science going on there in the deep oceans. We actually in Planetary collaborate a lot with the earth science folks on ocean research. Because I don't know if you know, but some of the moons of the big planets, the moons of Jupiter and Saturn, they're covered in ice, but underneath the ice are big oceans of salty water. So we work with the earth scientists to better understand those ocean environments so we understand for Planetary. So that's my part of that. Okay, I'm going to go way to the back corner over there, way back in the top back corner, red shirt, orange shirt. Yell loud, orange shirt. Where will the stamps? Tomorrow. Here is where the event is, but it's open to the public. You can come tomorrow morning at, what time was it? 11? I think it's at 11 o'clock tomorrow morning here, and that'll be the release. I think there will be some available there, then you will be able to get them from your local post office. Okay, good question. Okay, right down in front, one question.
Are you allowed to go to the landing site?
Am I allowed to go to the landing site? Yes and no. So let me just say, so I get to go out to Dugway on Sunday morning. I will be out there in the hangar where we're going to do the live broadcast. You'll see me there on the broadcast at some point. So I'm close by where we're going to be landing. So I'll be on base, but I will not be out right where it lands because nobody is going to be out. We want it to be safe. So no one's allowed in that area where it's going to land, so no one gets hurt. I will not be on the helicopter going to pick it up. We have specially trained people going out to do that, and that would not be me. So, okay, let's see. Let's go to another question over here, maybe down in front, over here. Yes. Yes. From Dugway. You might. I'm not sure how visible. It's very small. Again, when it comes down and it's not glowing, it's only about the size of a car tire. So when it comes down, I'm not sure you're going to actually be able to see it actually land, even though you're very close. I'm not even sure I'm going to be able to see it from where I am. Because again, it's not very big and it's going to be kind of soft. Maybe we can see the parachute, maybe. Is that big red and white parachute? Maybe we'll see that. I don't know. I'm going to look for it. If you see it, give me a call. Yeah. All right, let's see. Let's do another one. Let's come down here. Changed like last minute. Was there ever a need to have a landing site changed like at the last minute? That is a really good question. It is. And I'm trying to think, certainly from our planetary missions, I don't know of one. All of our missions for the United States, we've had several, the Stardust mission, Genesis mission, and and OSIRIS-REx now, all landing in Utah. Some of our other colleagues around the world, like Japanese Space Agency, when they have brought samples back, they use the deserts of Australia. That's where they land theirs, out in Woomera, Australia. But I don't know of anyone ever changing that landing site. The challenge is when it comes in, it's going where it's going to go. So there's not a lot of opportunity to move it to a different location. That's where it's headed. You bet. You bet. Okay, red shirt. I'll go back over there next.
What do you think of Glaze? How is that?
Okay, it's an alien question. There's always an alien question. Thank you. Thank you. We've got the requisite alien question. So I will give you my my opinion first, which is that I do not think we're alone in the universe. I feel like we have, as I said, these asteroids that are delivering the same organic molecules and water to all of the planets. We know there are thousands upon thousands of other planets just in our nearby galaxy. So I feel like it's pretty arrogant to think we're the only ones out there. I think it's possible there's something else out there. But to your second part of your question, unidentified aerial phenomena, which now the government is now talking about and saying, yes, these things, we have seen things that we don't know what they are. There is zero evidence that any of that is of an alien origin. There are things that we have seen that we don't understand. And what NASA's doing is putting together, we have lots of data, right? We got a gazillion satellites orbiting Earth all the time, taking images of Earth all the time. And we're going to take advantage of all that and use those data to help us better understand what these phenomena are that we're seeing. So hopefully that answers the question. All right, let's come to the middle right here. Denim jacket. Okay, let's talk doctors. So I said NASA has a lot of doctors. I don't know that there's necessarily not a NASA doctor on site at Dugway for this. I imagine the military has their own medical facilities, and if there were an issue, we've got that. So we don't have a doctor on the facility, a medical doctor. But we do have medical doctors at all of our NASA centers, and then we have a chief medical officer, I think is what his title is, at NASA headquarters. And he's the one who really provided us, for example, a lot of guidance during the pandemic on how we can be safe and keep all of our colleagues safe when we were at work. So we definitely have doctors on our staff, but not necessarily on site for this landing. And for the astronauts, of course, medical safety of the astronauts. We have a whole crew of medical doctors for the astronauts. All right, in the back with the black shirt, right there. Yes. Are you going to put another rover on Mars? I hope so. So right now we have 2 rovers on Mars. We got the Curiosity rover, which has been on Mars. How long has it been on Mars?
10 years.
More than 7. No, not 17. It's about 10. I think it's 11 or 12 now. It's about 10. And then we've got, that's Curiosity, and then Perseverance has been on Mars since 2021. 10 trillion, okay. Perseverance has been there for 2 years. Right now, Perseverance rover is collecting samples of Mars because just like we want to bring back samples of the asteroid Bennu, we would really love to get our hands on a sample of Mars. We have a lot of meteorites from Mars, but we don't have any samples from Mars that we actually know exactly where it was taken and what the material is. So Perseverance is doing that now. The next mission will be a mission to go grab those samples. That's not a rover, it's a lander, and Perseverance will rove to the lander and deliver the samples. But I imagine sometime in the future there will be, and I expect there will be more helicopters on Mars too. Okay, let's come over here in the middle. Yes, right there. Pink hair, from as near as I can tell from here. I'm sorry, say it again, a little louder. Oh, how do I keep my passion alive in an era of misinformation? Ooh, boy, that's a deep, deep question. I work really hard to try and provide as much accurate information as I can. Sometimes it's hard in an environment where there is a lot of misinformation out there, but we work really hard at NASA to provide as much information that the public can trust. that we're open and we're honest and we're transparent about what we do. We try and make all of our data available as soon as possible. And so that's our goal, is just to try and do as best job we can. And learning about our planet, learning about all the planets in the solar system and our place in the universe, to me, that's just one of the most exciting jobs anyone could have. So I once said, I got an interview one time and I said, it's the science that gets me up in the morning. Still true after all these years. Okay, right down here in front. Yes, yes. I'm sorry, can you say it again a little louder? Oh, something unexpected. Okay, the question is, what if there's something inside our sample that we're getting from the asteroid? Yeah, that's unexpected. So I imagine there will be something unexpected. We always learn something new, but I don't think it's going to be anything dangerous. This asteroid, Bennu, has been traveling around the solar system for 4.5 billion years, being exposed to the radiation from the sun and the deep cold of space. And so I don't expect there to be anything dangerous in this asteroid, but I do think we're going to learn something new that we didn't expect. That's why we do the science, to learn things we didn't already know. Let's do one down here in front with the glasses. Can we land on the sun or the rings of Saturn? That's an interesting question. Landing on the sun, no. It's a little hot. However, NASA's getting as close as you possibly can to the sun. There's a mission right now called Parker Solar Probe, which is the closest we've ever gotten to the sun. And just for the folks in the room, the rings of Saturn are made up of little pieces of rock and ice that are actually not that close together. They look close together, but they're not. So there's nothing actually to land on there. Okay, let's go back up to the back, straight in the back. Yes, blue sleeve, way in the back. Are we sure that there's no explosive property in the sample? Yes, we are confident there's nothing explosive in the sample. Okay, right here.
Is there going to be a commemorative plaque or something held where it lands? Or is that just
a commemorative plaque out on Dugway where it lands? That is an excellent question. I'm going to assign that to some of my my crack staff here to find out if we ever put a plaque somewhere for Genesis and Stardust, and whether or not that's something that could be commemorated. I don't know the answer, but if I had a voice in it, I would say, let's do it. I think we should. I think this is a great partnership, to be honest, between various different agencies in our federal government. To be able to see the different branches of military working with NASA and all working together to do something wonderful. So I think that would be great. I want to let someone who hasn't asked a question ask one. You can ask one. Yes. Do we live on Planet 9? Oh, do I believe in Planet 9? There's something there, yes, because we can tell by orbital dynamics, right? We just haven't seen it yet. So I think there's something, but we don't know what it is yet. I'm going to go back up there first. I'll come back down. Let's go here. Black shirt. Yes.
what has been your favorite part?
My favorite part about Utah so far. So on this particular trip to Utah, I have been here for less than 24 hours. So maybe less than 12. I'm not sure. About 12. But that said, I've actually been to Utah many times before, and I love Utah. I think it is absolutely beautiful. I think being out here in the desert is absolutely stunning scenery. I think it's a lovely place. I used to have family that lived in Logan. I actually used to have family that lived in Tooele in the distant past. So I've actually been here many times, and I think it's a wonderful, wonderful spot. I'm going to come over here, green shirt. Is it blue? Is it green? I have a hard time seeing the color. It's awfully dark in here. Blue. Thank you for the correction. That is an awesome question. Is it possible that we would find living organisms in the sample? I'm going to say pretty definitively that I think there is zero chance of finding any living organism in the sample. And while it may have those organic molecules that we know in the right environment could lead to biology, could lead to microorganisms, it has to be the right environment. As far as we understand how life can form, it takes liquid water for a very, very long time. It takes energy. like either solar energy or thermal energy or chemical energy, in order for life to actually start to grow. And an asteroid just doesn't provide those things. It may have the basic elements, the piece parts, but you don't have liquid water. It's out there in the deep space where it's super, super cold, and you're getting irradiated by, radiation from the sun, which basically kills off anything that could possibly be living. Let me take another one down here, way over there against the side.
Is there any goal to mine Bennu eventually and kind of put it orbit around the moon, and then
Interesting question. Is the goal eventually to mine the material on Bennu, maybe bring it in closer in an orbit around the moon? There's a lot packed into that question. So I'm going to take it apart in different pieces because it's a really interesting question. Okay, so first, number one, NASA isn't going to mine any asteroids, okay? But that doesn't mean there aren't private companies out there that have talked about mining asteroids. I mean, there are potential resources. In fact, one of the R's in OSIRIS-REx, it's an acronym, one of the R's is for resources, trying to understand what kind of resources there might be. In this case, we're talking water, right, that could be used by astronauts for fuel or liquid water to drink, or to turn it into oxygen and hydrogen. But even then, there was actually a concept 15 years ago where someone talked about, let's go capture an asteroid and put it in orbit around the moon. Technically feasible with a small asteroid. Bennu's far, far too big for us to be able to move it. That Dimorphos, the little asteroid that we hit with the DART spacecraft, that guy was 140 meters. It's the size of a high school football stadium, and we moved it, 33 minutes out of 12 hours. So moving an asteroid is pretty hard to do. So I think at this point, with the technology we have today, it's pretty impractical. But there's been a lot of talk about it. There's interest, not by NASA, but by others. So who knows what the future could bring. 75 years ago, we didn't know we could land on the moon. So there's a lot of things that can happen. All right, let's go back up here. I got a whole cluster up there. Who wants to go? Okay, black sweater there, black shirt. No. The question was, can I say anything about Area 51? And I already answered my alien question, so I'm done. No Area 51. Okay, let's see, up here, white shirt with the green design on it. Oh, my prediction for the next planet we're going to explore. Ooh, that's an exciting question. So let me tell you. So we've had missions that have studied Mercury. We've had, a long time ago, we had some missions that studied Venus. It's actually been neglected for a while, but we're working to send some more missions back to Venus. We've got, as you know, like a whole fleet of missions that are studying Mars. We've got several missions at Jupiter. We've had a mission at Saturn before, and we had a mission that went to Pluto. So which ones are missing in that catalog that we didn't go to?
Neptune.
Neptune and Uranus. I'm going to say Uranus here today. So yeah, those are two planets that we flew by them with the Voyager spacecraft. So we have some nice pictures, but we don't really understand. They're actually some of the most unknown parts of our solar system. So we actually, every 10 years, we put together a big list of what is the highest priority that we need to put our NASA money on if we're going to go do planetary science. And the number one recommendation out of that study was go to Uranus. So if I had to predict, I would say the next one's going to be Uranus. Okie dokie. In the very back, white shirt with the green design on it. Yes. Oh, great question. How do I know the parachute's going to work and what's going to happen if it doesn't work? So we have learned over the years how important it is to test. And so we have tested the system, not just the parachute itself, but the system that actually gives the signal that says it's time to deploy the parachute. It's been tested over and over again. And so while we can never be 100% positive everything's going to work the way it's supposed to, we have done everything we possibly can to be confident up to like a 99.9% confidence that that parachute is going to open. In the event that the parachute doesn't open, we have studied that. We've looked at that contingency. And we know that if that were to happen, the capsule is still going to land within that ellipse that I showed you on the map. It's still going to land in a safe place. It's not going to hurt anybody. It's not going to land outside of UTTR. And what would happen most likely is it would land a little harder than 10 miles per hour, right? And so if that happened, the outer shell of the capsule would probably break. We call breach. We say it gets breached. And what that means is that the sample inside would be exposed to Earth air. And so I said we want to keep it as pristine as possible. We would recover it as quickly as possible and button it up in a container that's got a lot of nitrogen in it to try and keep it safe. We do that as quickly as possible. Those samples would still be incredibly valuable. We lose a little bit of the science that we wanted to do with those pristine samples, but we'd still get a lot of really good science. Okay, let's come back over here. Blue shirt with the vest on, with something on your head. Oh, I'll say this one up here. I'll come back to you in just a moment. I'll get you next. Right here. Yes? Yeah, you. The green color. I have not done any research on it. I have heard of it. I don't have enough detail with me right now to answer your question. I will apologize for that. I apologize. I don't know that. Okay. We got a NASA shirt. Okay. You have to ask a question. You have a NASA shirt on.
Yes. Thank you. About dimorphos, have you been able to figure out anything about the composition of dimorphos based on how you hit it and your study of the ejecta afterward? And is it a rubble pile or is it something else?
Great question. So the question here is about dimorphos. That was the little asteroid that we hit with the DART mission. And how do we learn anything about what it's made of, what its composition is? It is a rubble pile that we know from how we hit it, and we know by how it responded to when we hit it, right? The momentum transfer when we hit the asteroid, we know that it was a rubble pile, and we have some sense of the density of the asteroid itself. Actual composition, all we have are the Earth-based measurements that we have. It's a carbonaceous asteroid. Interestingly, the European Space Agency, our partners over on the other side of the Atlantic, are building a mission right now. It's called Hera, and their mission is going to fly back to Didymos and Dimorphos and do a much more comprehensive survey of both asteroids to give us more information about what they're made of, their composition. Hopefully they'll be able to see the crater that we made with the DART spacecraft, and we'll get some more really cool information. Right now we have mostly information about dynamics, less about composition, but we'll have that once Hera gets there. Okay, let's see. I'm going to come back over here. Okay, yes, right there, blue. How do rovers know how to move by themselves? Is that the question? Okay, this is a really cool question. So I told you we have some pretty amazing scientists and engineers at NASA. And the rovers on Mars are managed by a bunch of engineers out at the Jet Propulsion Laboratory in California, and they're pretty clever. And what they've done is they, like every day or so, they get information back from the rovers. It comes down through some of our satellites orbiting around Mars. And it says, okay, here's how the rover's doing. Here's where we are. Here's what we can see in front of us. And then we send a plan back up to the rovers that say, okay, for the next day or the next 2 days or 3 days, this is what we want you to do. And then the rover executes that. There's special software on the rover so it knows what to do. We actually improved between Curiosity and Perseverance. With Curiosity, we had to say, drive 6 inches, stop, wait for us. Drive 12 inches, stop, wait for us, and we'll assess the obstacles. Perseverance has the ability to say, I'm sitting here, I want to go to that spot 100 meters away, football field away, drive, figure it out. And the rover has the smarts to figure out how to go from A to B and avoid the obstacles and find the best path. So that's a pretty cool self-driving car technology is happening on Mars. Okay, let's go down here, right in the, oh, you already asked one already, so let's go to somebody else here. In front. Yeah, go ahead. Is it going to be on the news on Sunday? It darn well better be on the news. I think it's going to be on the news. Yeah. Usually when things like this happen, we get a lot of news coverage, and this is going to be a pretty fun one. Okay, right here.
On this guy's question, are we, it's on the base, right? So it's closed to the public. We couldn't like pile outside the fences and like, hey,
Who's going to tell me what the, for the guest stops? What's open for folks?
Out on the base.
I don't think anyone's on the base.
No.
No, I don't think on the base. Yeah, there will be stuff here, watch parties.
I mean,
Yeah.
if you're watching
Oh,
the
no
live
kidding.
feed,
Yeah, it would be pretty cool.
You'll see the most.
Dial in on the TV.
That's probably your best bet.
Watch
TV.
nasa.gov/live, nasa.gov/live. That's where they'll have the live streaming of the whole broadcast, and you'll be like right there in the driver's seat. That's going to be your best view, to be honest. Super cool. Okay, over here. Yes. How old was I when I started working for NASA? So my first job was at a Jet Propulsion Laboratory. I got that job when I finished my master's degree. So I'd done my bachelor's, I got a master's degree. I wasn't quite ready to get my PhD yet. And so I started working out at JPL. I must have been 23. So I was 23 years old. After about a year at JPL, I went, I really want to go get my PhD. So I worked at JPL for about 5 years, and I got my PhD while I was working there at JPL. And so then I went to Goddard Space Flight Center when I was 30. So that's kind of my trajectory. Okie dokie. Oh, we got two hands. All right, two hands. Has NASA ever talked about building a Dyson sphere? No, but I love that Star Trek episode. It's awesome. Okay. It's so good. All right. Let's see. I got two red shirts here. Go. Yes. Yes.
So in how many years do you estimate that they'll actually do a mission to Uranus?
How many years before we do a mission to Uranus? Ooh, now you sound like my scientists that I go and talk to, and they're like, come on, Lori, when are you going to fly that mission to Uranus? And I say, I need more money. So I'll be honest, it does take a lot of money to start these missions up. I've got a lot of scientists that are ready. They've studied the mission to go to Uranus. They know what they want to do. So we've got the will, we've got the technology. I just need the dollars at this point. And so right now, we're probably looking at a mission that might launch in the mid 2030s if I can get it all together and get the money together this decade. We'll see how our Congress decides what they would want to do with us. So that's the big if. We can answer a couple other ones here. Let's see. I'm gonna come back over to this side, then we'll come back over here. Let's see right here. Black shirt. Yes. On the little kid, you had your hand up. Oh, for him. Okay, go. Will the moon ever crash into Earth? Interestingly, the moon is moving away from Earth very slowly, but every year as it rotates around, it's getting just a little bit further away from Earth. So no, it won't run into Earth, but you know that the moon formed during a giant collision with Earth, and actually the Earth and moon are made of the same material from that collision. So there was a big collision, a bunch of stuff blew off of the Earth and it flew around the Earth, and then that all came together to make the moon. So how cool is that? So it formed from a big collision with Earth, but no, the moon is not going to collide with Earth. Okay, coming back over here, back over here, back over here. Okay, gray shirt right here. Yes, you, yes. How many missions have I done so far? So I'm at NASA headquarters, and so I get to oversee all the missions. You know, my job is to, kind of look at them and say, yes, y'all are doing the right thing. But I've been really lucky. I oversee right now in our planetary science what I call my fleet of planetary science missions. I have 37 missions in my fleet. I had 3 more last year, but 2 of them completed their work successfully, and so they came out. One was DART that ran into the asteroid, so that one's done. Another one was on Mars. It completed its mission. And then I had another one that was supposed to launch that we had to say, no, it's time to stop. So they're not going to launch. So now I have 37. Okay, right here.
The moon is slowly moving further and further away. How long will it take before it just leaves for its times?
That's a great question. And I don't know that I know that answer. But yeah, eventually, presumably, it would escape Earth's gravity. But I think that is an extremely long.
It might be after the solar system has expired.
Yeah, after the solar system has expired, probably. Yeah, I would agree with that answer. And this is a lunar expert right here. This is my colleague, Shoshana Weeder, works with me at NASA headquarters, and she is a lunatic. All right, I'm going to come back over to this side again. Back over here. Red and black checkered jacket back there. Could we theoretically send a spacecraft out into space with a camera just to see what's there? Sure, theoretically we could do that. In general, we want to learn as much science as possible. Each one of these missions is kind of expensive, and so we want to make sure we get the most science we can out of every mission. So we actually do have some really cool spacecraft that are out in the outer part of the solar system. That same spacecraft that flew by Pluto is still flying out way past Pluto. There's a bunch of, we talked about different types of asteroids in the solar system. There's a whole nother collection of those small bodies out by Pluto called Kuiper Belt objects that are even more pristine than the asteroids that are near Earth. And so that spacecraft is still taking pictures out there in the outer part of the solar system. The 2 Voyager spacecraft from the 1970s are still operating. They have left the solar system. They passed the edge of what our sun can touch, called the heliopause. And so they've now left the solar system. They don't have cameras on them, but they are sensing their environment. They're still providing some really interesting data outside our solar system. So we're kind of doing that in a lot of different ways to sense what's around us. Okay, right here, white shirt.
2 questions?
Maybe. That was one. Okay. Do black holes really bend time? They certainly bend space, yes. We can actually see things that are behind black holes because it bends, the intense gravity well actually bends light around them. So yes. What's the other question?
Time travel.
Not yet. We don't have the technology for that, but we can use it to see things that are hidden from view, which is pretty cool, called gravitational lensing. And we use that in astrophysics to be able to see bodies out in the universe. Okay, we've got someone waving desperately over there. Desperately, yes. Wow, we're talking about money. Someone wants to know, how much did OSIRIS-REx cost? Okay, throw me some numbers. What do you think? 200 million? 2 billion? Okay. All right. Okay, I heard some good numbers out there. I'll give you the answer. I know the answer. I know. You know the answer? Oh, for a new question. Okay. The answer is $1 billion. Like for real, $1 billion. It's a lot of money, but I will tell you the samples that are going to land here in your backyard on Sunday are priceless. They will tell us things that there's no other way to learn except by looking at those samples. So it's really hard to put a price tag on those samples. But yes, $1 billion spent between 2011 and 2025. So that's all spread out over a very long period of time. And a pretty amazing investment, I would say. Yes.
So is it possible to land on a black
Is it possible to land on a black hole? No. Black holes are a gravity well. You would get sucked in and you would implode. So probably not a great ending. Let's see, in the back. Yes.
Two-part question. Is there any kind of testing for biologicals on the sample that's returning to Earth?
Was there any kind of a test for biologicals on the samples returning to Earth? So the data that we have from orbiting around Bennu while we were there indicate that, yeah, there are probably some organic minerals and molecules on the surface, but nothing indicative of life at all. Nothing that looks like complex organics that could ultimately be something that's alive.
And did you see the promise?
Of course. And no. We have brought, there are, as I said, we have meteorites on Earth that fall all the time. So we have extraterrestrial material on Earth all the time, from asteroids, from Mars. We have that material here on Earth, and we're all still here. So I think that's a pretty good story. Excuse me? 100,000 tons a year. I don't know the number, but maybe it's a lot. There's a lot that comes down. Yeah. Okay. Just a moment. We'll come back. I'm going to come back over to this side of the room right here. Black shirt. Yes, you. And then the one behind you there also. Go ahead. You go first. Okay, you're getting into deep astrophysics about white holes and black holes. I am not an astrophysicist. I am a planetary scientist. I work inside my solar system. You are asking a question that is outside of my realm, but it's a great question. Next, right behind. When will the sun explode? Okay, I think we're starting to digress here. Let's take a couple more questions. I don't know how much more time we have, but maybe one or two more questions, and then we're going to wrap it up. I'm going to, right here, please.
Yeah, you mentioned trip to Mars, trip to maybe Uranus, and you also talked about some of these ice world or ice moons. Which would be, do you think, a higher priority for NASA to go to like Enceladus with a liquid ocean underneath, or to go to like Uranus?
Okay, great question. We talked about the different places we want to go. I talked about the high priority of going to Uranus or Neptune, but Uranus is the one we're working on. And the question is it higher priority to do that or go to one of these icy moons that potentially could be a place where life could exist in an ocean? So one mission I haven't talked about here is something that we call the Europa Clipper mission. So we actually have a mission. This one's going to launch 1 year from now in October of 2024. And that's a spacecraft that's going to go explore Europa. Europa is a moon of Jupiter. Europa has an icy crust, several kilometers thick, a few miles thick of icy crust. And underneath that icy crust is a global ocean that we know is a salty ocean. We also feel like there is most likely volcanoes, hydrothermal vents beneath the ocean at the base on the floor of the ocean that could drive, what did I say life needs? Water, like an ocean, and it needs energy. So if you have the volcanoes on the bottom of the ocean, that's thermal energy, it's chemical energy, and it would recycle the water within that ocean. And so we actually think the moon of Europa, the moon of Jupiter, Europa, is a place that, or Enceladus at Saturn, could be a place where there is life. So Clipper is a spacecraft. It's not going to land, but it's going to do a lot. It's got 10 instruments on there that are going to map out Europa and help us better understand that environment so that if we want to land there, we'll have that information. But we're kind of a ways off from having that enough information to land and to think about how we would access that global ocean. So Uranus still comes first, but I think Europa or Enceladus will be fast on that maybe in the next decade. That's my guess. I'm just speculating. All right, one more question. Make it a good one. Okay. Young lady here in the red and black. Yes. If I could visit one body in the solar system with the caveat that I could survive, I would go to Venus. I have a special place in my heart for Venus. I studied Venus for a long time. I studied the volcanoes on Venus for a long time. I did a lot of work to develop mission ideas for NASA to fly to Venus. And I think that would be just incredible to be able to stand on the surface of Venus. Unfortunately, the surface of Venus is hot enough to melt lead. It's about 450 Celsius, which is 700 and something in Fahrenheit. The pressure on the surface is 100 times what you feel here on Earth. And so it's like being a mile underwater. And so if you wanted to be on the surface, if you didn't have the guarantee you could survive it, you would probably implode and burn up very fast. Okay, I think we're going to wrap it up there, if that's okay with y'all. Y'all have been an amazing audience. Watch Sunday morning.
All right, let's have one more really big round of applause for Dr. Glaze. Thank you so much. That's a great question. All right, we know you've got places to go and things to do. You can exit the theater either at the top corner up there or down here. Thanks for coming out and helping us have a great event. There's lots more to come. Stay tuned.